Hello guys, today we're back looking at the Hitachi Zaxis 210. It's been a long time since we looked at that. This is the first excavator that I tried to convert. So you can see I was using servos. Now if I spin it around here, you can see I had a servo in here, but it kept burning out because this is all diecast and it's quite heavy. So another thing I tried, I don't know if I ever actually put it in a video, but about 5 years ago I think this was, I tried to 3D print some sort of a bracket that would sit here to lift it, but obviously the 3D printing part just came apart like that in just different layers, so that wasn't a very good idea really. So today what I'm thinking to do is we're going to continue with this screw drive idea, but I have this brass, I think it's M4 possibly, or sorry, 4mm outer diameter, and I have an M3 insert, and it just so happens that the inner diameter is pretty close to the insert outer diameter. So there's little teeth on the outside of here. I'm going to try and tap this into our brass rod here, and if that doesn't hold it, if it starts to spin when we're trying to lift our arm, we'll just solder the brass piece in, because they're both brass. Should be able to solder them together if we have to. But for starters, we're just going to try to press fit, because that is obviously the easiest option. Okay, so the first thing we need to do anyway is take it apart, because I don't really remember what was in it. So we have to figure out what we're working with first. I know there is an XB module in the cab, but I'm probably going to change that because it's not really the way I want to go now. Everything else is using NRF 24 modules, so I think that is the way I'll try and keep this as well. So we have to do a little bit of modifications to the electronics. Okay, so we're into the model now. Clearly it was all controlled by an Arduino Pro Mini. We have TB6612FNG motor driver here. There is a little power supply, I forget the name of that exactly, but basically it takes the power from this 7.4 volt battery and brings it down to 5 volts. So that's probably the power we were sending to our servos. And that's pretty much all there is there, I think. There's another IC under there, I don't know what that is, but we'll take it apart because we'll probably replace this stuff. Well, that could be another motor driver to drive the tracks maybe, because there's two continuous rotation servos here. So I'm not sure how this is wired. We'll reuse some of this, I'd say. I'm gonna have to disconnect this, because what we want control of, or what we need to modify really, is the boom. So we need to get that part apart. This is the XB module. I'm not going to use that anymore, so not much use for that. Okay, so what we're interested in this video is really modifying this part of the build. We're not too worried about the rest. So just that pin was holding on this little connection here. I'm going to kind of do it the opposite direction. When I did this before, I put the motor on this side, but this time I'm going to mount the motor down this side, and I have this 3D printed little motor casing. We have two motors to try. This one is geared down pretty low, so it's going to be quite slow. This one is geared higher, so it's going to be quicker, but it might not have the power to lift the boom. So we're just going to have to work that out. We can probably reuse this pin, just need to open these holes out slightly. On the boom side though, we are going to need to cut a slot up the center of this, so that we can get this 4mm tube in here. Then in the middle of the arm, this bolt hole here that's actually a post that goes straight through, so we're going to have to cut a slot in the middle of that so that we can put an axle through here to catch this rod and make a pivot point, and then we'll be able to thread that up and down to get our boom to move. Okay, so I made a few changes to the boom here. We've cut this section out of both sides. That's going to let our new brass tube here with the threaded insert in it. So the threaded insert's there. Probably not going to be able to see that. The threaded insert is pressed into this side, and on this side there's a hole through here which is going to line up with this pivot point here, and I've just cut a little piece off that pivot point so that there's enough room for the brass tube when we put these two together. So it's going to be hard to see, but just in there is just a gap in the middle there. So the idea is that this is the pivot point. Our brass tube is going to pivot around that. So something like that. That will be in there, and our motor will be here. So this point will be on this pivot, be threaded into the brass tube, and in that way we'll be able to screw it up and down. So that's the idea. I'll throw it together now and just show you how it works basically. Okay, so I have it all back together here. I have the boom extended as far as it will go. That's just to make sure that we have the most weight that we're going to experience on it. I'll just put this on here as a counterbalance. So that should keep the back of the model down. Yeah, so because this is all die cast, we want to make sure we're able to lift all the weight of this. Whatever goes in the bucket, it's not going to be all that heavy. It's probably going to be coffee grind or a little bit of soil, but it won't be much weight relative to the weight of the boom itself. So this is the faster motor. I put the slow higher powered one on earlier, and although it well obviously had lots of power, but it was really slow. It wouldn't be usable. It'd be way too slow. So obviously down works. Swap the wires around. That's the boom climbing. I'm using the 7.4 volt battery here to test. So not crazy. It was a 7.4 volt battery that was in the model, so we might have to stick with 7.4. Not crazy fast, but I think that's a reasonable speed. You don't want to be waiting all day for the boom to raise or lower, so I think that's going to be alright. I think for now I'll just leave the servos to control the tap I'll focus on rewiring the back of the model. But at the minute we've no feedback for this motor, so what'll happen is when this screws out to the maximum, the motor doesn't know that the arm physically can't go any further, so it keeps trying to push, and most likely we're going to break this 3D printed bracket here. So to prevent that, I'm going to add in some feedback in the next video. But that's all for today. We have a motor that'll raise the boom, and now we just need to add some limits. So I hope you've enjoyed this so far. The next video, like I say, will be with the feedback, and we'll have to take a look at the wiring itself. But that's all I have for today. If you liked the video, don't forget to hit the like button, and if you want to subscribe and get the bell on so you'll get notifications. But that's all I have for today. Thanks very much for watching.